welcome back to the final three. This is November 2018 paper 3. This is a calculator paper. If you'd like to see the questions or the paper that this particular question comes from, please do look at the description below. This particular series is only concentrating on the final 3 questions of all the exam papers since November 2017, since June 2017, sorry. So if you want to look at my channel, you can catch those exam papers and find your way through those. This is really suited to those people who have already done the hard part of the revision, looking at getting those 8s and 9s. So if that's you, I wish you all the best with summer. I hope you do really well. And if you're new to the channel, please do leave a like and a subscribe. That will help me out a ton. Right, so this is question 18. This is talking about a high-speed train. And again, as soon as you're reading this question, you're realizing quite quickly this is about speed, distance, time. So speed mentioned, you've got distance and time there. So again, I'm going to write down real quick speed, distance, time as a triangle. So we've got that understood really quickly. And then we have got to think about all of these things being thought through. So it's talking about distance measured correct to the nearest kilometre, and time measured correct to the nearest minute. That's important. Also talking about considering bounds. So it's saying by considering bounds, work out the average speed. Now when it says consider bounds and it's talking about speed in the same sentence, you're now going to be thinking about the maximum value of the speed and the minimum value of the speed. That's what you're trying to do. There's a question I did very similar to this in a previous exam paper, so you might want to check my channel because I've done a question very similar to this. I think it was either June 2018 or maybe the previous one, but you'll see it comes out very similar. So when you see consider bounds and then whatever you've got in that particular sentence, that's the thing you're concentrating on. So we're going to concentrate on working out the maximum value of speed and the minimum value of speed. I'm going to go back to the question and start looking at this information. So it says the distance is measured correct to the nearest kilometre. So if you look at our distance 487, what would it have been at its smallest value? So what's the distance minimum? So the distance minimum will be 486.5, and the distance maximum, whatever that was, that will be 487.5. Okay, so that's got to be that. The time, again, similar, it's measured to nearest minute. So this is 180 minutes. So it's 179.5 minutes and then 180.5 minutes. So I'm just making a note of all these first. Okay, so make sure the point shows up well on the camera because I can see it's not showing up too well. That makes it a bit better, I think. Okay. So we now want the speed, the minimum speed. The minimum speed will be the minimum distance divided by the maximum time. So this divided by this. So 486.5 divided by 180.5. That's the minimum speed. The maximum speed will be this divided by this. So the maximum distance divided by the minimum time. So 487.5 divided by 179.5. Again, it's calculator paper, so I'm going to sling these into the calculator. 180.5. So 2.695290.859. Okay, so you write down the whole thing, and that's fine. And again, we're going to do this one. So 487.5 divided by 179.5. 2.7158774737. Now, back in the question, it says show it to a suitable degree of accuracy. So it's very important that you when you get questions on suitable degrees of accuracy, you look at these two answers and see how they round. So both of these are 3 to the nearest whole number. Then you look at 1 decimal place. Both of them are 2.7 to 1 decimal place. So they both agree to 1 decimal place. Do they agree to 2 decimal places? Well, no, they don't, because this is 2.70 and this is 2.72. So they don't agree 2 decimal places. So you stop where they agree. So it's 2.7 again, it will be kilometers per minute. Okay, because both these problems, both these answers round to 2.7. So both, it says give a reason. So up here it says give a reason. So both speeds, maximum, minimum, round to 2.7 kilometers per minute. So you've written down a bit of explanation there to show them that, and that will get your 5 marks. It's quite a nice use of 5 marks. That it's not massively challenging at this stage. Number 19 is one of our old friends. It's a non-linear simultaneous equation system. I've done this question before, so there's a whole video devoted to simultaneous equations, non-linear simultaneous equations. So if you want to check that out, please do check my channel. I've done a whole load of these, including I think this one. But I'll do this one again just to show you. So we've got these two problems. We need to see, okay, how we rewrite this. So again, it makes most sense to rewrite it as 1 minus 2y. And then wherever I see an x squared up here, I'm going to write 1 minus 2y. So 1 minus 2y squared. So again, 1 minus 2y squared, if I work out what that is, I'll write it up here. So we have 1 minus 4y and then plus 4y squared. That's what you get when you multiply these 6 things out. So I'm going to have 2 lots of 1 minus 4y plus 4y squared minus y squared equals 17. If I multiply this out by 2, and then gather together the like terms, try and write it a bit nicer for myself. So 7y squared minus 8y and then minus 15 equals 0. Okay, because 2 minus 17. So I've done a little bit of collating together, you get this. Now, this is the calculator paper. So I'm somewhat surprised that this is factorizable, but it is. It is factorizable, but you should be prepared to do the formula and things in the calculator paper. But this one is factorizable. So again, just a reminder about how you would go about doing factorization when you've got a coefficient of in this case y squared. You do 7 lots of minus 15. That's minus 105, and you're looking for numbers that multiply to make 105, but then also add to 8. And again, if you try different values and combinations out, you'll very quickly get to minus 15 and 7 work. So it's 7y squared, starts the same, and then you're going to have the 7 goes with the 7, so plus 7y minus 15y minus 15 equals 0. And again, if you take out what's common from the first pair, you get 7y, y plus 1, and then take out what's common from the second pair, you get 15, and then y plus 1 equals 0. And again, these two things will be then written as one combined problem. So 7y minus 15y plus 1, which is going to mean that y is either 15 over 7 or minus 1. X, therefore, if you go back to up here, we said that x is 1 minus 2y. So by substitution, you can do some substitution in here, and you'll get really quickly. I mean, you can use a calculator, but you can get it really quickly. X is minus 23 over 7 or 3, I believe. So those are the sets of values that you get, and you just write down by substitution here, just to tell the examiner that you've done it by substitution, and that will get you your 5 marks. Okay, so you need both sets of solutions. Don't always, the key error is people always leave it as y and never do the x bits. So make sure you do get both the x values and the y values as pairs. Question 20 finally is a really straightforward last question. There's just a little bit of explanation around one thing which I need to mention, but apart from that, it's not that challenging. It's only worth 2 marks, so not especially challenging. It's talking about a transformation, talking about a combined transformation, rotation of 180 degrees, and then a translation vector. So you do need some tracing paper for this. I don't have tracing paper here, so what I'll do is I'll use this plastic overlay to show you what's going on. So earlier on, I just coloured in the triangles, so you can see that I've done that. Okay, we're going to rotate it 180 degrees about the point -20 first. So the point -20 is here. Okay, now again, I'm going to rotate it 180 degrees. So you can see where it ends up somewhere about there. So I'm going to draw that shape in because I want to show the examiner the thinking that I did. So I'm going to draw that shape just to sketch it in, just in case there's any marks for that. So I'm going to just lightly shade that in. And then it says that this is done, translated by a vector -3, so 3 that way, and then 2 up, so 2 up. So three along, so 1, 2, 3, and then 2 up, 1, 2. That's where the shape ends up. So it's just underneath there, underneath A. So we're going to have a diagram that looks a bit like this. Okay, so this is what the image looks like. So this is A dash. Okay, and then it says on one point on triangle A is invariant under the combined transformation. Find the coordinates of these points. Now, invariance is where you have a point that does not move, that does not change its definition. What point is that? It's actually this point right here, because this point is the bottom of the triangle in the original shape, and it's the bottom of my triangle in my transformed shape. So it's this point that's invariant, and that is -3.5 along and then 1 up. So it's -3.5, 1, and that will get you the 2 marks. Okay, that's the end of November 2018 paper 3, and that concludes for now the channel for the final 3. I'll keep adding them, so when we have the exam for the summer, June 2019, I'll add those in as well. And if you're revising for your exams for summer, I do wish you all the best and hope you do really well. Keep an eye on the channel because I'll be adding new content in the next few weeks, and if you want to suggest some new things, I do have a comment section below, so please just go ahead and suggest things that you'd like me to do in the future. Okay, good luck and hope to speak to you soon. Bye bye for now. Bye bye.